When multiplying or dividing measured values, your answer must be rounded in a specific way. So what I want to talk about here is how to deal with multiplication and division when it comes to rounding to the right number of sig figs. So in problem 74, you can see I've gone and figured out the quotient for 34.5 divided by 6.7. And that's written in the rectangular box, which again represents the calculator display. Of the two numbers divided, the 6.7 is the number with the fewest number of sig figs. In fact, it only has 2 sig figs. What that means is that your final rounded answer must contain 2 sig figs. So the rule is basically the rounded answer must contain the same number of sig figs as the measured value with the fewest number of sig figs. Sounds complicated, but just follow along, and in a couple examples you'll have it. So since 6.7 only has 2 sig figs, I'm only allowed 2 sig figs in my answer. Now the first number in my answer is of course the 5, followed by the decimal point. And so far I have written 1 sig fig. I'm only allowed to write 1 more. Now I can write as many insignificant figures as I need to, but I can only write 1 more sig fig according to the rules. So the 1 is the next number I would write, but I need to look at the number that follows, and of course that's a 4. Now the 4 does not round the 1 up. Remember, 5 and greater rounds up, less than 5 rounds down. So this stays as just 5.1. That is the final answer. Now I didn't write down units for any of these problems, just for simplicity, but all of these, let's treat them as measured values with units. In 79, the product is 36.608. Well, multiplication is done the same way as division. The first number contains 3 sig figs. The second number contains 5 sig figs. So the 5.00 is the number that provides the guidance in terms of how many sig figs are going to be in our answer, namely 3. So the 3, the 6, the decimal point, I'm allowed 1 more sig fig. That's going to be the 6. The number that follows is a 0. That doesn't influence the 6, so it's simply 36.6. Now here's a great set of problems, 81, 82, and 83. Of course, if you were to punch these into a calculator, they would all say the same thing, 25. But that's the answer if we're dealing with pure numbers. And we're not dealing with pure numbers. We're dealing with measured values with a limited number of sig figs. So in the case of 81, both numbers being multiplied only have 1 sig fig. So our answer can only have 1 sig fig. Well, of course, the 2 is influenced by the 5. 5 and greater rounds up, so I'm going to write a 3. Now, of course, that is the first and only sig fig I'm allowed to write in the answer. But 3 could not possibly be the right answer for 5 times 5. It's nowhere near the original answer in the calculator. So this is a kind of problem that often trips up students. And what I would tell you in a case like this is remember that the rounded answer and the calculated answer are always reasonably close to each other. 3 and 25 are different by more than 8 times. So there's no way that this is correct. So I can get closer to 25 by putting a 0 after the 3. And now I have 30. Now 30, 30, only has 1 sig fig, which is all I'm allowed in this case. And 30 is a much better representation of 25 than 3 is. Now if you're careless and you write 3, 0, and you drop a decimal point there, now you have a trailing 0 with a decimal point present, and now that 0 counts as significant. Now you have 2 sig figs, and that answer, of course, would be wrong, even though it's the same size as the number 30. Very tricky. In the case of 82, of course, the calculator says the answer is 25. But again, we're dealing with a number that only has 1 sig fig. So I have to write 30 to represent the calculated answer. It's not until you get to problem 83 where both numbers have 2 sig figs that you're allowed to write 2 sig figs, 25. And now the rounded answer and the calculated answer are exactly the same. And of course, that's really the most ideal. Now, in the case of 85, 150.0 times 4.00. Listen, on a calculator, this is the same as punching in 150 times 4, and the calculator, of course, shows an answer of 600. But looking at the two numbers, this number here, oh, excuse me, didn't want to do that. Hang on, folks. Now, in the case of 85, 150.0 times 4.00, of course, you can type this into the calculator as 150 times 4, and that is 600. But of these two numbers, this number only has 3 sig figs. The other number, of course, has 4. So my answer can only have 3 sig figs. Now, the way it's shown in the calculator right now, 600, that, of course, only has 1 sig fig. Again, we have trailing zeros with no decimal point, so they do not count as significant. So the number 600 only has 1 sig fig. This is not permissible as an answer under the rounding rules for sig figs. So what I need to do is to create a circumstance where I have 3 sig figs in my answer. And in this case, that can very easily be accomplished by just putting the decimal point. So now I have trailing zeros with a decimal point. Those zeros now count as significant. Now I have 3 sig figs in my answer. Now, sometimes students struggle with cases like this, and they come up with all sorts of really unique solutions to the problem. And I do sympathize being in this predicament. I really do. So some of the answers that we've gotten through the years are really quite clever. Students obviously realize that 600 did not have the right number of sig figs, so they have tried answers like 601 and 599. And those are really kind of very good wrong answers because the student that wrote either of these answers realizes that the rounded answer has to be very close to the calculated answer. And of course, 601 and 599 are both very close to the calculated answer of 600. But they also communicated another piece of understanding to me, and that was that they knew the answer had to contain 3 sig figs, which both of these numbers do. But they're still not the correct answers because the best answer that represents the calculated answer to the right number of sig figs is 600 decimal point, not 601, not 599. Those students got close to understanding what we're talking about here, but they didn't quite get all the way.